Hello, everybody. In today's lesson, we're going to be working on lesson 2.1 of the sixth grade Go Math textbook for middle school. And our topic today is the greatest common factor. And so the essential question basically that you should be able to answer at the end of our lesson is that how can you find and use the greatest common factor of two whole numbers? So let's look at the explore activity number 1 and to get an understanding of common factors. So the greatest common factor of two numbers is the greatest factor shared by those numbers. All right. And so here's a question. A florist makes bouquets from 18 roses and 30 tulips. All the bouquets include both roses and tulips. All bouquets are identical and all the flowers are used. So to solve this, we can make tables to see the possible ways that the florist can use to make the bouquets. So let's complete this table here. So if I had one bouquet, there has to be 18 roses in each bouquet, right? Because 1 times 18 is 18. If I had two bouquets, there would be 9 roses in each one. 2 times 9 is 18. If I made 3 bouquets, 3 times what is 18? 6. Okay, if I made 6 bouquets, how many roses would be in each one? 3. If I made 9, there would be 2. And if I made 18 bouquets, there'd be only 1 rose in each bouquet. All right, now let's look at the tulips. So there's 30 tulips total. If we had only 1 bouquet, there would be 30 tulips in it. If we had 2, 2 times what is 30? Well, 2 times 15 is 30. 3 times 10 is 30. 5 times 6 is 30. 6 times 5 is 30. 10 times 3, 15 times 2, and 30 times 1. So let's look at some of the questions related to that now. Can the florist make 5 bouquets using all the flowers? In this case, the answer would be no, because 5 is not a factor of both numbers, right? I can't multiply 5 times anything to get 18 roses. So in that case, I would be left with, if we had 5 bouquets, I'd have 3 roses left over. All right, so no. 5 is not a factor of both. We could also say 18 is not divisible by 5. Okay. All right, so what are the common factors of 18 and 30? And what do they represent? Well, I see 1 in both. I see 2. 3 is a factor of both. 6 is a factor of both. And that's it, right? So we have 4 common factors. What do those factors represent? Well, they represent the number of bouquets that can be made using all the flowers. Okay. So 1, 2, 3, and 6 are the common factors, or the number of bouquets that we can make using all of the flowers. So what is the GCF of 18 and 30? G standing for the greatest. So of these 4 common factors, which one's the greatest? Well, that's 6, right? All right, so now let's reflect the what if thought here. Suppose the florist has 18 roses and 36 tulips. What is the greatest common factor of the number of roses and tulips? Well, we know in this case that the greatest factor of 18 would be 18, right? Well, 18 is also a factor of 36 because 18 times 2 is 36. So the greatest common factor would be 18. So again, the greatest factor of 18 is 18, and 18 is also a factor of 36. So the greatest common factor is 18. All right, let's move on. Page 32. So let's continue finding the greatest common factor. So one way to find the greatest common factor of two numbers is to list all of their factors. And that's basically what we were doing in exercise 1 or activity 1. Then we can identify common factors and the greatest common factor. So let's look at example 1. A baker has 24 sesame bagels and 36 plain bagels to put into boxes. Each box must have the same number of each type of bagel. What is the greatest number of boxes that the baker can make using all of the bagels? And then how many sesame bagels and how many plain bagels will be in each box? All right, so step 1, basically let's list the factors of 24 and 36. So the factors of 24, well, we know 1 times 24 is two factors that have a product of 24. Is 2 a factor of 24? Yes, because 2 is a factor of any number that is even. 2 times what is 24? 12. 3, will 3 work? Yes, because 2 plus 4 is 6, and 6 is divisible by 3. So 3 times what is 24? 3 times 8. 4? 4 times 6 is 24. 5 will not work because 24 doesn't end in 5 or 0. We already know 6 will work. 7? No. 7, 14, 21, 28. 8 we already know works. 9, 18, 27, so no. All right, so we basically have all of our factors of 24. Then we go to 36. Again, 1 times 36. 2 times 18. 3 will work because 3 plus 6 is 9, and 9 is divisible by 3. So 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. And you notice that we only write the 6 once in this case. So then, what do all the circles mean? Well, the circles are all the factors that are in common to both 24 and 36. So what's the greatest common factor? Well, just what's the largest number that is circled in both? 12. Okay, so the greatest common factor is 12. So the greatest number of boxes that the baker can make is 12. And in that case, there will be 2 sesame bagels, because 12 times 2 is 24. And there will be 3 plain bagels, because 36 divided by 12 is 3, or 12 times 3 is 36. So what's the greatest common factor of 2 prime numbers? Well, remember that the definition of a prime number is that a prime number only has exactly 2 factors, 1 and itself. So the greatest common factor of any 2 prime numbers has to be 1. An example would be 5 and 3. The only factors of 5 are 1 and 5, and 3, the factors would be 1 and 3. So the only thing in common is 1. All right, so let's find the greatest common factor of each of these pair of numbers. 14 and 35. Well, we know 1 and 14 is factors. Will 2 work? Yes, because 14 is an even number. So 2 and 7. Will 3 work? No, because 1 plus 4 is 5, and 5 is not divisible by 3. Will 4 work? 4, 8, 12. No. 5 is not a factor of 14 because 14 does not end on 5 or 0. 6 will not work because 14 is not divisible by both 2 and 3. 7 will work. We already know that. 8 will not work. 8 times 2 is 16, not 14. 9 will not work. 9, 18. Okay, so those are the only 4 factors of 14. How about 35? Well, we know 1 and 35. 2 will not work because this is not an even number. 3 will not work because 5 plus 3 is 8, and 8 is not divisible by 3. 4 will not work because 35 is not an even number. 5 will work. 5 times 7. 6 will not work because 35 is not divisible by 2 or 3. 7 we know works. 8 will not work because, again, this is not an even number. 9, no. 9, 18, 27, 36. So those are the only factors of 35. So what's the greatest common factor? Well, let's circle the ones that are already common. So it's 7, right? All right, how about 20 and 28? All right, so we know 1 and 20. 2 and 10. 3 is not a factor. 4 is. 4 times 5. 6 is not a factor. I know that because 3 was not a factor of 20. 7 is not. 7, 14, 21. 8 is not. 8, 16, 24. 9 is not. So those are the factors of 20. And so 28. We know 1 and 28. We know 2 will work. 2 and 14. 3 will not work because 8 plus 2 is 10, and 10 is not divisible by 3. 4 will work. 4 times 7. 5 will not work because it does not end in a 5 or 0. 6 will not work because 3 was not a factor of 28. We know 7 works. 8 will not work. 8, 16, 24, 32. And 9 will not work. 9, 18, 27. So those are the factors of 28. Let's circle the common factors. So it looks like the greatest common factor of 20 and 28 is 4. All right, number 5. The 6th grade class is competing in the school field day. There are 32 girls and 40 boys who want to participate. Each team must have the same number of girls and the same number of boys. What is the greatest number of teams that can be formed? In other words, what's the greatest common factor? And then how many boys and girls will be on each team? So we basically have 32 and 40. So we need to list the factors of those. Well, 1 and 32, 2 and 16. 3 will not work because 3 plus 2 is 5. 5 is not divisible by 3. 4 will work. 4 times 8 is 32. 5 will not work because 32 does not end in a 5 or a 0. 6 will not work because 2 and 3 are not factors of 32. 7 will not work. 8 we already know works. And 9, 18, 27, 36, no. So those are the factors of 32. 40, we know 1 and 40. 2 and 20. 3 is not a factor of 40. 4 is. 4 times 10. 5 times 8. 6 was not a factor of 40 because 2 and 3 are not both factors of 40. 7 is not a factor of 40. 8 is. 9 is not a factor of 40. So these are the common factors of 32 and 40. So we could have one team. We could have 2 teams, 4 teams. We could have 8 teams. So those are the greatest common factors. So the greatest common factor or greatest number of teams formed can be 8 teams. 8 times what is 32? 4. So there would be 4 girls and 10 boys on each team. Again, 8 times 4 is 32. There were 32 girls. Oh, not times. 8 times 10. Sorry. 8 times 5. Because there's only 40 boys. 8 times what is 40? 5. So 4 girls and 5 boys on each team. All right, let's move on to page 33. Using the distributive property. So we can use the distributive property to rewrite a sum of 2 or more numbers as a product of their greatest common factor and a sum of numbers with no common factor other than 1. So to understand this, we can use grid paper to draw area models of 45 and 60. And here are all the possible models of 45. Well, we could definitely have one row of 45, right? 1 times 45. 3 is also a factor of 45. 4 plus 5 is 9. 9 is divisible by 3. 3 times 15 is 45. And 5 times 9 is 45. So the factors of 45 are 1, 3, 5, 9, 15, and 45. So what do the numbers 1, 3, 5, 9, 15, and 45 represent? Those are the side lengths, right? They're the factors of 45. Okay, if you have grid paper, you can do the same thing to show the dimensions here for possible models of 60. So I'm just going to draw it out. 1 times 60. I could have 2 by 30. Will 3 work? Sure. Because 6 plus 0 is 6, and 6 is divisible by 3. So I'd say 3 times 20. Is 4 a factor of 60? Yes. 4 15s is 60. 5 will work because 60 ends in a 0. And that would be 5 times 12. 6 we know will work. 6 times 10. 7 will not work. 8 will not work. 9 will not work. And we know that 10 will work. So we could have a 10 by 6 times 10. So we just really wanted to list all the factors. Okay, so we're not listing just different, like if I turn these sideways, we could have a 60 by 1, a 30 by 2, so on. But the factors don't change. So what are the factors of 60? One times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. So what side lengths are in common to 45 and 60? Well, they both have 1 in common. 3, yes, they both have 3 in common. 5, yes. 9, no. 15? Yes. 45? No. So 1, 3, 5, and 15 are the common factors of 45 and 60. What's the greatest common length? Well, 15. What does that represent? The greatest common factor. So we're going to write 45 as a product of the greatest common factor and another number. So the greatest common factor of 45 and 60 was 15. So 15 times 3. And the greatest, writing 60 with the greatest common factor would be 15 times 4. So how can we rewrite 45 plus 60? Well, we can rewrite it as 15 times 3 plus 15 times 4. And we can rewrite this again using the distributive property to write it as a product of its greatest common factor and the two numbers. So 15 times 3 plus 15 times 4 is the same as saying 15 times the sum of 3 and 4, which would be 15 times 7. All right, so let's look at number 6. So we're going to practice this. 27 and 18. So let's list the common factors of 27 and 18. Factors of 27 are 1 and 27. 2 is not a factor. 3 is. 4 is not. 5 is not because it doesn't end in 5 or 0. 6 is not because it's not divisible by 2 and 3. 7 is not a factor of 27. 8 is not a factor of 27. 9 is. Okay, so there's only 4 factors of 27. 18 is 1 and 18. 2 and 9. 3 and 6. 4 is not a factor of 18. 5 is not a factor of 18. 7 is not a factor of 18, nor is 18. So what's the greatest common factor? Well, we have 1s, 3s, 9s in common. So we can write 27 as 9 times 3, and we can write 18 as 9 times 2. So 27 plus 18 is the same as saying 9 times 3 plus 9 times 2. And that equals the same as saying 9 times the sum of 3 plus 2, which is the same as saying 9 times 5. Okay, so the greatest common factor was 9. So 9 times 3 is 27. 9 times 2 is 18. And we can rewrite that as 9 times 5. All right, number 7, 120 plus 36. Well, we know 1 times 120 is one set of factors. 2 and 60. 3 and 40. 4 and 30. 5 and 24. 6 and 20. 8 and 15. and 10 and 12. Okay, 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12 are all factors of 20. Well, 120. 36 is 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 times 6. So the greatest the common factors are 1, 2, 3, 4, 6, 12, okay? So the greatest common factor of 120 plus 36 is 12. So we can rewrite 120 as 12 times 10 and 36 as 12 times 3. So it's the same thing as saying 12 plus 10 plus 12 times 3, which equals 12 times the sum of 10 and 3, or 12 times 13. Okay, number 8, 9, and 35. The greatest common factors of, or factors of 9 are 1 and 9 and 3 times 3. That's it, right? 4 doesn't work, 5 doesn't work, 6 will not work, 7 will not work. 35, we know 1 and 35. 2 will not work, because 35 is odd. 3 will not work. 4 will not work. 5 times 7 will work. 6 will not work. 8 will not work, and 9 will not work. Well, those are the only factors of 35. And so the only factor in common is 1. Okay, so if 1 is the greatest common factor, we would rewrite 9. We'd rewrite 9 plus 35 as 1 times 9 plus 1 times 35, which would be basically just 1 times the sum of 9 plus 35. So it would be 1 times 44. Okay. All right, let's move on to number 1 on page 34. Okay, Lee is sewing vests using 16 green buttons, 24 blue buttons. All the vests are identical and all have both green and blue buttons. What are the possible number of vests Lee can make? What is the greatest number of vests Lee can make? All right, so we're going to list the factors of 16, 1, and 16, 2, and 8. 3 is not a factor of 16, 4 is. 4 times 4. 5 is not a factor of 16. 6 is not a factor of 16. 7, 8 is. 9 is not. 10 is not. Okay, so those are the only factors of 16. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. So what are the factors in common? 1, 2, 4, 8. What are the top possible number of vests Lee can make? 1, 2, 4, and 8, right? He can make 1 vest, he can make 2 vests, he can make 4 vests, or he can make 8 vests. The greatest common factor is 8. So the greatest number of vests she can make is 8. All right, so let's rewrite 36 plus 45 as a product of the GCF and another sum. All right, so what's the greatest common factor of 36 and 45? Okay, so those are what you should come up with for 36. 45. Okay, so the common factors of 36 and 45 are 1, 3, 9. Okay, the greatest common factor is 9. So now how can we rewrite this? So 36 would be 9 times 4. 45, using the greatest common factor, would be 9 times 5. So now rewrite that using the distributive property. We'd have 9 times the sum of 4 and 5, which is also the same as saying 9 times 9. All right, what's the greatest common factor of 75 and 90? Well, we know 1 times 75. 2 is not a factor of 75. 3 is a factor of 75 because 7 plus 5 is 12. So, and since 12 is divisible by 3, 75 is divisible by 3. So 75 divided by 3 would be 25. 4 will not work. 75 is not even. 5 will work. 5 times 15. 6 will not work. 7 will not work. 8, 9. Okay, so those are your factors of 75. 90. We know 1 and 90. We know 2 and 45. We know 3 will work because 9 plus 0 is 9. 9 is divisible by 3. So 90 is divisible by 3. 3 and 30. 4. Will 4 work? Well, we can check, right? So, no, there's going to be a remainder there, right? 4 is not a factor. 5 is, because it ends in a 0. So that would be 5 and 18. 6 is a factor of 90 because I see that 2 and 3 are factors of 90. So 90 divided by 6 will be 15. 7 is not a factor of 90. 8 is not. 9 is. 9 times 10. Okay. So those are our factors of 90. Now, which ones are in common? 1, 3, 5, 15. The greatest common factor is 15. So we can rewrite that as 15 times 5 to give us 75. 15 times 6 to give us 90. So we can rewrite it as 15 times the sum of 5 and 6, which is the same as saying 15 times 11. All right, so suppose you write a sum of the numbers as a product of their GCF and another sum. What is the GCF of the numbers in the other sum? In other words, so what's the greatest common factor of 4 and 5? What's the greatest common factor of 5 and 6? The greatest common factor will be 1. And if it's not 1, then we didn't find the greatest common factor to start. All right, moving on. All right, number 5. List the factors of each number. All right, what's the factors of 12? Well, 1 and 12, 2 and 6, 3 and 4. 5 is not a factor of 12. 6 is. 7 is not. 8 is not. 9 is not. So those are our factors of 12. Factors of 50. Again, we know 1 and 50. We know 2 because 50 is an even number. And if we think of that as money, then 2 quarters, right, would be 50. 3 is not a factor of 50 because 5 plus 0 is 5. 5 is not divisible by 3. 4 is not a factor of 50. Closest we could get with 4 is 4 times 12. 5 is, because 50 ends in a 5, ends in a 5 or a 0, then 5 times 10. 6 is not a factor of 50 because 2 and 3 are not factors of 50. 7 is not. Closest you can get using 7 is 7 times 7. 8 is not a factor of 50. 9 is not a factor of 50. So we have 6 factors of 50. 1, 2, 5, 10, 25, 50. Okay, number 7. 39. Well, we know 1 and 39, right? So go ahead and list 1 and 39. 2 we know is not a factor of 39 because 39 is not even. 3 will be because 3 plus 9 is 12, and 12 is divisible by 3. 3 times 13 is 39. 4 is not because 39 is not an even number. 5 will not work. It doesn't end in a 0 or 5. 6 will not work. The closest you can get is 36 plus. For 6 to be a factor of 39, it also has to be divisible by 2 and 3. 7 is not a factor of 39. 8 is not a factor of 39. And 9 is not a factor of 39. Okay, so we only have 4 factors of 39. And 64. Well, we know 1 times 64. We also know 2 will work because 64 is even. And 2 32s would be 64. 3 will not work because 6 plus 4 is 10. 10 is not divisible by 3. 4 is a factor of 64. 64 divided by 4 is 16. 5 will not work. 64 does not end in a 5 or 0. 6 will not work because it's not divisible by 2 and 3. 7 is not a factor of 64. The closest you can get is 7 times 9, which is 63. 8 times 8 is 64. 9 times 7 is 63. That's the closest you can get. So 9 is not a factor of 64. Plus 6 plus 4 is 10. 10 is not divisible by 9. 10 is not a factor of 64. Okay, so we have 7 factors of 64. All right, now find the greatest common factor of each pair of numbers, 40 and 48. Okay, so list the factors of 40, the factors of 48. 1 and 40, 2 and 20, 4 and 10, 5 and 8,